May th, the Indianapolis turns to chaos. Fire engulfs the track. 2 drivers lie dead. Ford's revolutionary engine, a secret project years in the making, teeters on the brink of disaster. But how did a British chassis, an Italian carburetor, and a renegade Ford engineer spark this tragedy and ultimate triumph? The truth. Detroit's greatest racing engine was born from betrayal, blood, and a feud that nearly destroyed Ford Motor Company. By IndyCar racing was a museum. The Offenhauser AFI engine, AS Relic, had one straight Indy S. Its creator, Fred Offenhauser, ruled like a mob boss. Teams feared innovation. But one man saw weakness. Don Frey, Ford's Maverick VP. His plan? Build an engine so radical it humiliate Offie or get him fired. Gentlemen, we're not just building an engine. We're starting a revolution. Frey's weapon, a secret skunkworks team. Bill Gay, Ford's advanced engines chief, Mauro Ferrieri, consultant, and Phil Remington. Shelby Cobra genius, a weight-obsessed engineer. Their mission? Shrink a Fairlane Vito cubic in, add dual overhead cams, and make it scream to RPM. Insiders called it Project Suicide. While the Indy has seen some of the wildest and most innovative American race cars ever built, it was also one of the least creative races in the world. By the S, one particular engine had completely taken over the race category. This engine was the Mir Drake Offenhauser engine. Originally designed back in the S, this engine had won every Indianapolis since, from 2 across races and possible qualifying spots. Offenhauser engines powered of them? Sure, there were a few exceptions. The Odd Novi, a Cummins diesel that grabbed pole position in, and even a Ferrari that showed up that same year. But make no mistake, this was an Offenhauser-dominated empire. It was also a roadster race. Even though talented builders put their own spin on the cars, the basic shape and setup of an Indy roadster stayed pretty much the same. Outside of a few daring experiments, everyone stuck to the same formula. And it would stay that way until someone forced it to change. Born in New York, Don Gurney was the race driver who in the early S got the attention of Ford and helped spark a revolution. In early Gurney won the Daytona Continental, the race that would later become the famous Hours of Daytona. That win connected him with key people in the racing world, and it didn't take long for Gurney's growing reputation to land him an Indy ride. The call came from Mickey Thompson, a legend in hot rodding and racing innovation. Thompson had a car designed by John Crosswaite, a tube-frame chassis, engine behind the driver, and powered by a Buick V. Thompson believed that with the Indy S displacement rules, the lighter Buick engine could be a real advantage. And weirdly enough, he was almost right. Gurney qualified 8th and ran solidly in the top all day until a transmission failure forced him out early. His first Indy ended in disappointment. But something much bigger was happening behind the scenes. You see, Gurney wasn't alone that day. He had invited a man who would change everything, Colin Chapman. Chapman, the brilliant mastermind behind Lotus, was famous for designing lightweight, simple, and brutally fast cars. At first, the Indy didn't mean much to him. It was just an American race. But Gurney, always a smart connector, convinced Chapman to fly out, even offering to pay for his trip. Once Chapman saw the race with his own eyes, he was hooked. On the flight from Indianapolis to the Monaco Grand Prix, right after the event, Chapman couldn't stop talking about it. He saw exactly what Gurney saw, a wide-open opportunity to win with smarter design, not just brute force. And Chapman wasn't the only outsider paying attention. Walking around the garages during that race was a man named Don Frey. Most fans wouldn't have recognized him, but Frey was the general manager of Ford's car division and one of the most powerful men at the company. As Frey looked over the field, he saw almost nothing but Offenhauser engines and one lonely Buick. To him, it screamed opportunity. Ford needed to be in championship car racing, and specifically at the Indy on race day. Frey bumped into Hot Rod Magazine's Ray Brock, a sharp, well-connected journalist. Brock casually asked if Ford planned to get involved at Indy. Frey's answer was, "Next year we plan to race one, maybe more cars here." No one at Ford even knew about that plan yet, including most of the executives back in Dearborn. But Frey meant it. When he returned to Michigan, he started rallying engineers and top brass to support his vision. By July, he organized a secret meeting with Dan Gurney and Colin Chapman. In front of a room full of skeptical Ford engineers and executives, Chapman laid out a plan with his trademark confidence. Some in the room scoffed. Others flat out rejected the idea. After all, when you've done something the same way for decades, even the smartest people can struggle to see a better way. Chapman's idea was beautifully simple. Build a very lightweight car. Use a small light Ford VM making around horsepower. Make fewer pit stops than the heavy roadsters and eventually crush the competition with speed, efficiency, and smart design. To Chapman, the heavy, clunky Indy roadsters looked like tractors. In his mind, Ford wouldn't just win, they would dominate. Among the men at that meeting was Bill Gay, Ford's executive engineer for the company's advanced engine section. After listening to Chapman, Gay decided to see for himself whether this British guy's bold claims held any truth. Bill attended a few races following the Indy and quickly saw exactly what Chapman had observed. Championship car racing at that time was suffering from engineering stagnation. It was a revelation for someone like Gay, who had never really studied the scene. After what he witnessed, Gay bought into the project completely. Once he was on board, the resources of the Ford Motor Company were fully committed, and the project moved forward in earnest. Ford recruited principal design engineer Bill Gay, Mararo Foreri, and Phil Remington, who focused specifically on managing the weight of the engine they would develop. They began developing the engine in-house, which is unusual in itself. Meanwhile, Colin Chapman's company, Lotus, would be responsible for designing and building the chassis, while Ford handled the power plant. We called it the double cross. It crossed off, crossed tradition, and crossed our fingers it wouldn't blow up. As radical-looking as the Ford Doc Indy was. It was actually based on a standard Ford production engine, the CI, in the smallest, lightest, and most compact engine of its time. In the Ford Fairlane, it made around horsepower. A hotter, expanded cubic inch version powered the first AC Cobras, cranking out a strong horsepower. Since Ford was targeting a cubic inch displacement for Indy, the small block VAS, the perfect starting point. Phase began with a stock cubic and Cobra engine producing around horsepower. Phase focused on squeezing maximum horsepower from a pushrod setup and benchmarking it against the dominant Offenhauser engines. Ford didn't just guess. They bought a genuine AFI, tuned it with the help of experienced Indy racers, and strapped it to their dyno. At first, it made horsepower at RPM. After fine-tuning horsepower, they also talked to winning drivers like Roger Ward and teamed up with legendary chassis builder A.J. Watson to study his roadsters up close. Ford left no stone unturned, meticulously mapping every bump, dip, and contour of the speedway itself. During testing, they uncovered a critical insight. Engines with high torque camshafts between and of duration performed better than those chasing only peak horsepower. High torque engines accelerated harder out of corners, leading to faster lap times, even if they gave up a few miles an hour at the top end. This changed everything. By the end of phase, Ford's internal report gave the green light to phase developing an all-aluminum cubic in Vita. First, aluminum blocks and heads were unperfect, but they were good enough for brutal Danino testing. The iron-sleeved block weighed just pound, and each cylinder head was a featherweight pound. It was a promising start to Ford's bold assault on the greatest American race. By the phase deadline of November Street, factory engineers had a running engine on their hands. Durability testing was ready to begin, but there was a problem with the carburetors. After crunching the numbers, Bill Gay and his team realized the Webers were too small. They were costing them power and might choke the engine. They needed bigger carbs, but Weber didn't make anything larger, and they weren't interested in starting either. Bill Gay wasn't taking no for an answer. He hopped onto a flight to Italy, determined to talk to Weber's chief engineer in person. Due to a kind act he had shown to the engineer in the past, Gay was given a listening ear, and Weber agreed to build special and fast carburetors. Back home, the new carbs were fitted. The engine roared to life on the dyno, hammering out horsepower at RPM. Durability testing pushed it even harder. Hours straight at full throttle and it passed. It wasn't just reliable, it was a monster. The next big test was at Daytona on January ND, Act 2, Lotus Lies, and Italian carbs. Enter Colin Chapman, Lotus Cunning founder. He promised Ford a featherweight chassis but hit a brutal clause. Engine failures are Ford's problem. Meanwhile, Ford's carburetor supplier, Weber, backed out. Engineer Bill Gay flew to Italy, smoked some cigars with a factory manager, and smuggled out prototypes. But the engine had a flaw. The valves danced like rattlesnakes. We lost 3 engines in a week. Chapman wanted out. It was like riding a rocket that might detonate. But when it worked, God, you could feel the future. A day tire test with Goodyear Firestone and the brand new Lotus race car. Ford engineers worked day and night, switching engines between 2 Lotus cars. Each engine saw 2 hours of punishing track time, and they held up beautifully. But there was a ticking time bomb. Valve spring harmonics. At certain RPMs, the springs vibrated dangerously, risking engine failure. One of the Daytona test engines lost a valve during a post-run inspection. If that had happened at Indy, it would have been catastrophic. Back at Ford's high-performance and special models operations building, the team scrambled. They needed a new solution fast. As a result, they launched the Phase 3 of the Indy engine program just weeks before the Indy fast-forward to the qualifying day. The Lotus-Ford showed up at the Brickyard and shocked everyone. Lowe's slung mezzanine in European style with an American hammer under the hood. The Lotus-Ford qualified second. It was faster, lighter, and more efficient than anything else on the track. On the race day, the Lotus cars ran strong, but tradition fought back hard. The Lotus cars needed fewer pit stops, but pit crews weren't ready for the new strategy. Fumbles in the pits cost them precious time. In the end, Jim Clark and the Lotus-Ford finished second. A stunning result, but it wasn't the win they wanted. Still, the message was clear. The rear-engine revolution had begun. IndyCar would never be the same again, and Ford's Indy V8 had proven it could take on the world. The Vengeance. And the Ford Motor Company faced a critical choice: evolve or be left behind on the racetrack. Ford's little pushrod for cranking out horsepower and pound-feet of torque had already been pushed to its absolute limits. At just pound, it was a marvel, but not enough for the future Ford envisioned. On May, DOHC Scussel of Ford presented a bold new plan to the Society of Automotive Engineers. Ford wasn't just going to tweak the old engine. They were going to reinvent it. The target was a screaming RPM. At that level, a traditional pushrod engine was simply out of the question. It was time for something completely different. The dual overhead camshaft Vita first-phase engines kept the old block crank, rods, bearings, water pump, oil pan, and gear drive. But on top was a brand new 4-valve Perslander dock head with pent-roof combustion chambers. First run was nearly untuned as it generates horsepower at RPM, but there were problems. The exhaust valves ran too hot thanks to the initial chamber design. And worse, the ignition timing went haywire because the camshafts twisted at high RPM, scattering the spark. The engineers had to revise the combustion chambers for better cooling and move the ignition drive from the back of the camshafts to the front, keeping spark timing razor sharp. Ford hoped Weber would come along for the ride again, but Weber refused. They'd done enough and weren't interested in designing new carburetors for one engine. So, Ford switched to a Hilborn mechanical fuel injection system. Low pressure, constant flow, simple, and brutally effective. One of the wildest features of the final engine wasn't even planned. Originally, the exhaust ports were underneath the intake ports the traditional way, but once engineers tried fitting the engine into a race car chassis, disaster. The exhaust had to run straight through the suspension, which is a no-go. The solution they settled on was to flip it and move the exhaust ports above the intake. This not only solved the packaging nightmare, but gave the intake runners a straighter, more efficient shot at the valves, boosting airflow and horsepower even further. Another interesting detail of this engine version is the block. Ford used the same pushrod block, even kept the cam tunnel. How'd they pull that off, right? They inserted a tube where the camshaft would normally go. This tube acted like a diffuser for oil drain back and even helped vent the crankcase. It also stopped oil from pouring onto the crank and turning into foam. The cylinder heads used in diameter valves, 4 of them per cylinder. The camshaft had a point lift of duration and a tight valve overlap. That's seriously aggressive. The cam followers were bought straight from Meir Drake, the same ones used in the Offenhauser engines. The valve springs ran pound of pressure when open and pound on the seat when closed. These heads were crazy advanced for the time. As cast, the combustion chambers were within of an inch of final specs. Thanks to the pent-roof design, traditional machining wouldn't cut it. They finished them with electrical discharge machining, EDM. And this was basically science fiction. Magazines called it a miracle of the modern age. No other race car on Earth had cylinder heads finished like this, and few even today. Phase engines were built and tested to fine-tune ignition, heads, and fuel systems. At one point, some engines had 3 spark plugs per cylinder. Turns out the extra plugs added complexity with barely any power gain, so they settled on 1 plug per cylinder. Now to one of the most visually amazing parts of this engine, which is the exhaust. After a ton of testing, they settled on in pipes, although in systems were developed for other chassis. The final engine weight was pound, just pound over the original goal of Phase 3. This beast, properly tuned on gasoline, generated horsepower at RPM and pound-feet of torque at RPM. Tragedy and betrayal. By Ford's double cross was ready. Bobby Marshman hit MPH in testing, but at Indy, Eddie Sachs's car erupted in flames. Chapman blamed Ford. Jim Clark, Ford's star driver, quit. Yet hidden in the wreckage was a clue. Marshman's engine unscathed. Ford's engineers discovered the truth. Dunlop tires, not their engine, caused the crash. Chapman kept his job, but Ford's revenge was coming. The truth was yet to be revealed. Fast forward to January th. Bobby Marshman tested the phase engine at the Ford facility in Kingman, Arizona. Marshman achieved speeds of up to mph with the new engine in his race car, marking the first successful run of the phase engine. During this phase, the engine was refined, addressing the previously identified issues with the Indianapolis dyno and testing different exhaust systems. By February, durability tests were in full swing. Arizona's harsh conditions provided the perfect environment to stress test the engine's endurance. In March, the team returned to Indianapolis. These tests would determine if the phase engine had what it took to dominate the Indy A. Top speed of mph was recorded, and the cars were hitting mph on the straights. The performance was impressive, both on the track and in terms of engine refinement. In April, Ford returned to Arizona for final testing. Fuel injection systems, maintenance checks, and where tests were the focus, ensuring that the engine was fully ready for the rigors of racing. Then came the Indy A race that would end in tragedy. 7 Ford-powered cars entered the race, including the likes of Eddie Sachs's, Bobby Marshman, and Jim Clark. A devastating crash took the lives of Eddie Sachs's and Dave McDonald, halting the race for over an hour. But the worst was yet to come. Bobby Marshman was in the lead, seconds ahead, with his sights set on lapping AJ Fit, but an unfortunate mistake. Going too low on the apron damaged the transmission plug, causing oil to leak. Marshman was forced to retire from the race. That left Roger Ward as Ford's last hope. Despite poor pit stops, Ward managed to finish second, minute and seconds behind AJ Fit, who went on to win the race. Ford executives were not pleased with the result. Lee Iacocca, a key executive at Ford, demanded a full investigation into the failure and even called for Colin Chapman's firing. Due to his insistence on Dunlop tires, Jimmy Clark swore off ever returning to the Indy, but somehow, Chapman retained his job by invoking a contract clause that allowed him to keep his cars. He continued to run them at USAC races for the rest of the season. Despite the setback, Ford's commitment to the project did not waver. Executives flew to England to offer Chapman a deal that significantly reduced his budget and his power within the team. But it came with the condition that Clark would return for one more run at the Indy. By Ford's dual overhead cam V program had evolved into a full-fledged race engine business. Louise Meyer, the legendary figure behind the Mir Drake Offenhauser engine, was hired to manage Ford's engine sales and service. Meyer set up shop in Indianapolis, where he sold engines to a growing number of customers. At the Indy, Ford Power dominated the field with entries in the race. Cars had their engines in the rear, and of those were powered by Ford. However, there was an issue. Most Indianapolis mechanics had little experience with an engine as intricate as the Ford dual overhead cam VTO solved this problem. Ford forbade anyone except their own team from working on the engines and made sure only their mechanics tuned the race cars. When the race started, Ford showed its dominance. Jimmy Clark, starting from pole position, led of the laps. The only time he was not in the lead was when he came into the pits for a stop, and AJ Foe stayed out. Clark's victory was a coronation. Leading the race from lap 2, and then again from lap 2, the pit crew, led by the legendary NASCAR Wood brothers, executed lightning-fast stops, with the first one completed in less than seconds. Ford's engines performed flawlessly, with only 3 failures among the Ford-powered cars in the race. The failures that did occur were due to issues like nitromethane use, transaxle problems, and clutch failures. Clark's victory, which was the first by a foreign driver, since showed Ford's commitment to racing excellence. Ford had taken a beefed-up passenger car engine, evolved it into a race-winning powerhouse, completely reshaped the competitive landscape in IndyCar racing. Within just 2 years, the Ford dual overhead cam engine had captured the hearts of racing teams. With more than engines on the grid, at the Indy, Ford's dominance would continue, making the Indy an iconic moment in motorsport history. The Ford dual overhead cam engine became a legend after it helped win the EDM, and finally in these wins showed how powerful and reliable the engine was, making it one of the most successful in the history of the race. Chapman said it was smooth like a turbine. You could feel the engineering. In the early Ford decided to hand over the entire engine program to a JFO, one of the biggest names in racing. The engine was rebranded as the Foy V, marking the start of a new chapter for both Ford and Foe in racing. In a surprising move, drag racer Jim Busby took 2 of the Foy engines and put them in a dragster chassis. He raced the car in a National Hot Rod Association NH event, where it won a trophy for Best Engineered Car. And after the event, Busby sold the engines to an IndyCar team, making a good profit. Have you ever wondered how such a seemingly impossible project, filled with obstacles and tragedies, evolved into one of the most successful engines in racing history? Jim Clark returns. Ford's engines, now nicknamed the Phoenix, dominate. Clark leads laps. Off he is dead. But what if Sachs's crash had ended Ford's gamble?